Hello, everybody.
Hey,
Hello. 5-4 day 3 the special cases.
Good afternoon, everybody.
Dress.
I have no idea.
15, 12.
All right.
West Ham.
Typically, hey, you guys have to get this, so you need to focus and pay attention. This is not easy. How many people feel like they understand the difference between the word and the word or in these compound inequalities? Can somebody explain in their own words the difference between and or? Go ahead, Cubon.
And graphs go this way. First off.
Sodaro.
What?
Okay, so
Oh, Alex.
He's like, and graphs go this way.
Did I say and?
you make the 2 points in closed or open circle and you shade in the middle of them. And for or problems, you do have like you're saying 2 points and then you draw out the
Why?
because well for and the variables in the middle, so it's like kind of like in that range of numbers, it has to be in the middle. And for or it just has to be, it has to be true.
For both of them, does it?
Yeah.
It only has to be true. Guys, does everybody agree for or ones? It only has to be true for one of the two cases. But for and ones, it has to be true for both of them. Does everybody understand that? Okay, that's kind of important. Typically, or problems, or inequalities. Everybody put your thumbs like, how do or typically go? Out, right?
Yeah,
This is
Alex.
or. Cuban, really, you've got to focus.
Alex.
Okay? So they look like this. We graphed them. There's some kind of number here, say like 3 and 7, and or ones typically go like this. Right? Because the stuff to the left of 3 is true, or the stuff to the right of 7 is true. It's an or.
Same numbers used for the other point.
I'm not sure. All right, with or inequalities, only one of the parts of the inequality needs to be true in order for the inequality, the whole inequality, to be a true statement. Okay? And inequalities typically look like what? Put your thumbs. How do and ones usually run? Because it's this and that. We're looking for the word, everybody say it, overlap. Guys, the only place these two things overlap is in the middle. And that's why they're and ones. Okay? Typically they look like this. 3 and a 7. We'll do filled in circles here. And the overlap of the two would be just the stuff in the middle. Okay? And for and inequalities, all parts of the inequality must be true in order for the inequality to be a true statement. Excuse me. Today, guys, we're gonna look at some special cases though that have different types of graphs than what we've seen before. All right, this is weird. All right, everybody, put your thumbs up in the air like a typical or one. Okay, typical or. You got a circle here, and it's or. It's that way or that way. Everybody agree? What happens? Everybody, put your thumbs pointing to your right. What if it were an or, and both things were going to the right? What would the solution be?
Oh, anything.
All
To the right or
numbers
left?
have
Would
it.
not be all real numbers, but
No
the stuff over here.
No, it'd be
Which one, Henry?
this
It'd be this one.
Why?
This one wouldn't even matter.
because it still goes that way. Oh, because that one's still greater.
Why
Because
couldn't
this one is still greater than this one. That's a good way to think about it, Nico. Okay? So on an or, we're talking or, this one don't even matter.
Oh, so the or ones are easier on the special cases.
We'll see.
Wait, so or one is what we did originally, kind of like one step.
Or one. Okay, now, everybody push your thumbs up going the other way. What if this were an or one and going that way, and this is true, or this is true?
This
What's the real solution?
Down.
Just this one, right? This doesn't matter. We're going to graph something like that. Is anybody smart enough to figure out an or that could be an all reals? How could or be all real numbers?
both sides equal the same thing?
Oh, I see. Oh,
No.
this.
No, because all that stuff doesn't count.
I know.
Nico,
If it's like that.
the stuff in the middle doesn't count.
No, they're the same number.
Oh, this.
That could be one of them. But how about an or that goes like this? Well,
We're not doing this.
This counts, and this counts. So if you have an or that kind of looks like it's going to be an and, but it's an or, that would be all real numbers. Everybody agree?
Yeah.
Okay? That's tricky. A lot of things to think about. All right. Done with the ors. Let's talk about the ands. Everybody put your thumbs back up in the air and pointing to the right. What if this were an and? Where are both things true?
On this one still.
No, not that one, because guys, not this one, because this stuff here
Oh,
is not true here. So what's the solution to an and one that goes both in the same direction? No, just this stuff.
How?
This doesn't matter.
Well, what about those things behind that?
That's a good question, Al. The stuff that's behind it is not a solution here, and it's got to be the over. Where do these two overlap?
On that dot.
Just here, and that way. So this doesn't count.
It's not really gonna make sense when you listen to it.
I know. I would agree. Because they can't see the thumbs.
Do
All right,
people
everybody push your thumbs up in the air,
actually
pointing to the left.
That makes sense because everything in here is not double. When you put an and like that one up there, it's double. You gotta think of it as
You're
double.
looking for the overlap. So put them up to the. If this were an and problem and your solutions came out like this, what's really the answer?
Oh.
Just this stuff. Just this stuff. Okay.
Or do that one.
But if it were an or, it'd be this one. You got to keep it straight. Very good, Al. Now, let's do the really tricky one. Put your thumbs like an or one. What if this were an and?
Oh, then they no solution.
No solution.
How's that tricky? How's that the tricky
Okay.
ones?
Can anybody come up with an and one with their thumbs that's all real numbers?
Yeah.
This isn't included here. This isn't included on this one.
Oh, here. Let's speak.
You can't.
That's not included on that one.
You can't.
So that.
Yeah, I got it.
That stuff's not included on your left one.
Wait, did Alec already do this?
This one.
This one. That's.
It's
It's
not-
impossible.
That's not even
It's
number line.
impossible. You can't do it.
It's impossible. You can't have an and all real numbers.
And it's
I don't think.
Is it vice versa?
Mr. Thompson and I were trying to figure it out. Mr. Thompson's here for Miss
Wait.
Schwitzenberg today, so we couldn't come up with one. If you guys can, that's great. All right, so those are all the possible things we did it with. Let's do it with real numbers now. You guys got to think. So now,
Is it the other way around? True. So you can't have like a no solution for or.
you can't have a no solution for or problems.
Way to go, Sean.
Okay, Nico, what website are you on?
I'm looking at how many views your videos get.
Not right now.
No, do the one that we were trying
Close
to
it.
find out.
Let's get through it.
The no solution on yours.
Yeah.
That's because 3 people.
All right. Blah 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 blah. Solve them. Let's do this. Okay. Here's an example of a special case. X is less than or equal to 9, or 2 plus 4x is less than 10. I'll do the hard one. The first one's x is less than or equal to 9.
It's really hard.
That's funny stuff, people. Come on. All right, everybody solve the second one.
What was the for and inequalities at the top?
Say again.
What was the for and inequalities at the top?
What do you mean, what was for and inequalities?
Oh.
Oh,
X is 2.
okay. It's not an equation.
X is less than
5 by 4. 5 by 4, x is less than 2. And then, guys, sneak the word or in between there. Okay? Lisa, read the solution from left to right as far as what we got when we solved them both. X is less than or equal to 9, or x is less than 2. Watch this. Throw your 2 and your 9, guys, on your number line. Okay?
But that would be a.
Does everybody agree?
Maybe an
I'm going to do one at a time. There's x is less than 2. There's less than or equal to 9.
I got it. Here
Okay?
goes.
Since it's an or.
Sometimes on my homework, that's
Okay? Everybody put your thumbs up in the air.
You're doing it wrong, man.
Pointing to the
How
left.
do we know if it's a special case or
Can't
not?
these be
It's-
all to the right?
It's a special case.
How do we know if it's a special case or not?
Because we're going.
Because we're going to it's an or and it's going in the same direction.
How would you know?
Can't
Well,
be all real
I don't think
numbers.
that's a
Come
good.
on.
Alex got a good question.
Wait,
I don't know if there's any way to tell whether it's a special case until you start looking at the graph solution.
Okay, but on regular ors, it'd be like the
Right,
two
right. Well, it's
equals-
clearly not a regular or because it would go outward.
It can't be all real numbers because
Mr.
there's
Yeah, it's not all. So who knows what the solution is?
Oh,
This one.
I got it.
Now, I don't know which one you're talking about.
I
The-
got
the
it.
dark circle.
Guys, the answer is all x such that x is less than or equal to 9.
That's not hard.
Because all of less than 2 is included on the less than 9, but also the numbers that are less than 9 are included in the less than 9 or equal to 9.
Except
And we're
for
talking about or, so we only want one of them to be true. So all x such that x is less than or equal to 9 is our set notation answer.
Except 2 though.
Because that's
Okay.
also less than
What
2.
about 2? Because it can't.
But 2's included, because isn't
Included
2
in
less
nine.
than 9?
That's all I just
So it's included in the 9. So basically, and you don't have to erase this, guys, but basically the whole 2 part don't matter.
What for ands, the first one matters.
If it were an and, it would have been the 2.
Oh.
Nico, question.
On the test, will there be like a section that just says special?
No, that's what they asked last period too. You're gonna have to pick them out of all the rest of them.
That's
Good question though.
Will there be like a star on
No, on your test I'll put a star next to your prompt there. So
there? Okay, thanks.
you're welcome. All right, who's got set notation or the interval notation down?
Frank, I did.
Henry.
Parentheses, negative infinity, comma, 9, bracket.
Done. Nice job, Henry. So there's the graph. Set notation, interval notation.
Okay,
And it's at negative infinity because it's in the limit.
No, it's negative infinity because it's anything that's less than or equal to 9 counts, so it goes all the way to negative infinity. Tricky. All right, try that next one. Go. You've got to think. Albano.
Why would and be the 2? The
Ah.
x.
Okay. So there's my 9, there's my 2. Where's the overlap of these two? Because this, my left, I got to do this right for you. My left one is not included here. And remember, it's going to be the over. Where do these two overlap?
Oh, it's all real numbers. It overlaps. All real numbers.
You know what the word overlap means? So where are these two on top of each other? Here and left.
Oh, no, not one is the line.
So if this were an and one, it would be the less than 2. This wouldn't count because these numbers are not included, are not solutions to this part. You got to think. Hey, you guys are going to have to practice this. All right, let's try the next one.
The next one's confusing when you're about to graph. The arrows are pointing opposite.
Might be.
No,
Plus
there's
2.
a flippy though, so it can't be.
4x is less than or equal to 24. I added 2 to both sides, guys, and then I flipped my inequality sign, my inequality problem around. Not because of the dividing and multiplying by a negative, just because I want my variable to be first. So x is less than or equal to 6, or, and there is a flippy over here,
Or x is greater than.
negative 18, 6, or divided by 3. X is greater than or equal to 6.
They're on the
Whoa,
same
gee,
thing.
same number.
But I told you, Henry.
On the second one?
I thought it was on.
But they're going opposite
Nico?
ways.
On the second one?
No, I didn't do this.
All right, so we got a 6. Watch, let's talk about this. Filled in circle, going to the left for the first part. Filled in circle, going to the right.
But why filled in?
It's an or problem. As long as one thing counts, it all counts. What's the answer?
So it's like
I think I got it.
number line.
What if one of the inequalities didn't have a line?
Then we put an open circle there.
Oh, I think I can write the interval.
You would?
the
No, but
sentence.
wait, what's the answer?
Wait, what if it
All
was?
x such that x is.
Less than or equal to 6 or
No.
greater than or equal to 6.
Yeah, but you got to say that better.
All x is 6.
All x. No, because it's an
X
or.
is equal to 6.
No. If it were an and, it would be just x equals 6.
All x such that.
Because let's just, it's an or.
Oh, I got it.
What numbers are not included here?
Everything but 6.
Oh, 6 has got a circle on it. A filled in circle.
And negative. Is it something to do with infinity?
What numbers are not included
They're
here?
all included.
So what's the
All
answer?
real numbers.
All real numbers. This isn't all reals. This is, guys, this is,
Oh,
This.
yeah.
What if it was a close?
every number is, so all x such that x is a real number. Because it's an or, as long as one of the things are, as long as one part is true, all of it's true. Well, everything's true with this type of graph. If this were an and, just the 6 would count. Because that's the only overlap of the two.
Got him.
Interval notation is easy.
Wait, which one? What if it was an open circle?
Yeah.
Negative infinity to infinity.
If it was an open circle, what would you do? Open and close?
If it were an open circle on both of them,
Not just one.
on just one, then it would still be all reals because the other one would
What
count
would
as
you put at the dot?
Oh, you would do it. One of them would be an open. You would put a closed because the closed part
What
takes
if-
precedence over the
what would-
open.
Oh, okay.
If they were both open, it would be every number except for 6.
But then what would you write what would you write for the
Set notation.
You would write all x such that x is less than 6, or x is greater than 6.
So you would have had it if it was.
Right.
you would've-
That's a tricky one. You might put that one on the test.
Don't.
So you guys gotta think. All right, let's try a couple more of
This
these.
isn't even that
Now an
bad.
and one.
Don't do that.
Everybody solve both these and ones. Watch what happens. Something weird.
Flippy.
Flippy.
Flipper.
Whoa.
Ah.
Make sure you put the word and in there. Addressing Nico and Al's question earlier, I think special cases are going to be when the arrows, the inequality signs are pointing in the same direction
At the end of the answer.
at the very end when you solve them, when they're solved. So, who's got this one? When is x less than or equal to -5 and x is less than or equal to 6?
Got him.
Put on the graph.
What do you think it is, Cuban or Olson?
What means set notation?
No, just on the graph. What do you think?
Graph, you put -5, and then 6, and your -5 would have a closed circle going to the left, and then your 6 would have a closed circle going to the left.
So what's the solution?
So
That
before there were
It's negative
special
5.
cases.
hey,
There's 5.
it's just the -5 stuff. The green stuff don't matter. Where's the overlap of the red and the green?
Why isn't the green so?
Right there.
Because guys, Nico, do you kind of know what the word overlap means?
Yeah.
When they're on top of each other? Where's the overlap of those two?
-5.
Here and over. Okay? So that doesn't matter. Guys, the solution is just all x such that x is less than or equal to -5.
Yes. Alright, can I write the initial
You should
notation?
do the vertical line.
Yeah, Mr. Pansini.
Say again. Go.
Wouldn't it be the right one? Because you want all of the space from the 6 to the 5, and then you want the 5.
Why do you want the stuff between the 6 and the -5?
Doesn't work out.
Because it's less than 6?
But it's not.
If it was an O, it'd be 6.
Yeah, we got yes. Al? The stuff in between the -5 and the 6.
Yeah.
Is that stuff included with the less than or equal to -5?
Yes.
No.
Well-
Doesn't work.
Is that stuff
-5.
included?
In the x, is the stuff in between here
Yeah.
included with this stuff?
Oh, no.
If you
No.
use the
No.
6.
So we're looking for and means both of them have to be true. Well, this in between stuff is not true for less than or equal to -5. So I'm not going to count it.
Oh, but for the or one, you count the.
Because as long as one of them's true, it's true. And both of them have to be true, or only one of them has to be true.
Oh,
So, like Briggs said, if this were an or, it would have been the less than 6 would have been the answer. Less than or equal to 6. But it's not an or, it's an and.
Can I write the interval notation?
Give it, go Cuban.
Parentheses, -infinity, comma, -5 bracket.
Perfect. Okay, that's your special case of your and. Let's try the next one.
Why was period 2 freaking out?
Yeah, I know.
Say again?
Why is period
Who's
2
freaking
freaking
out?
out?
You just have to remember, like, if it's an and they're all going the same way, you take the first number and put it in
Yeah.
the set number.
What if it goes that way?
You take the first one as
It
well.
would be the last number.
Well,
Okay, like, what I would know.
It's-
Outside.
Outside number, that might be a way to think about it.
Wait.
Alright,
They're
negative.
both outside though.
Flippy.
Oh, no, because they're both going inside.
Flippy.
Flippy! And I'm going to flip this one around. Even though this doesn't, this flips because we rewrite it, not because it's multiplying and dividing by a negative. This one bad. Okay, did anybody else get less than or equal to -4 and A is greater than 4.
I'm not there yet.
Yeah.
Okay. Somebody give me an A. Give me an answer that works here. Somebody give me an A.
Yahoo!
Bless you. Somebody give me an A here that's less than or equal to -4 and at the same time greater than 4.
Oh. Okay.
Quinn Livin.
This is a no solution.
This is a no solution.
Because there's nothing that's less than.
Watch when you graph it.
Okay.
Watch when you graph it. It kind of, and if you understand that ands have to be the overlap, watch this. Closed circle on the -4 going to the left. Open circle on the +4 going to the right. Where are those two things going to ever overlap?
Never.
Never. What do we write?
Never ever.
Unless they go
No.
around the world.
No solution, baby.
Oh yeah, somewhere in China they'll overlap. Issues. You all have issues.
Well, maybe. I mean, it's a circle.
Literally.
Or Russia, because it's so big.
Right. Or in Russia because there's a lot of space there. No
Next one.
solution. Okay, but it's cold.
Let me pause with that. He hasn't been on bug since April 1st.
All right, try 5. There's another and. Let's see what happens here.
I go, what did Daddy do?
X is less than 3. And
X is greater
oh geez. Is this one less than 3 and greater than or equal to 3?
than
Nah, so no.
Well, let's see.
And
Let's see.
and can't be all real.
There's
No,
3.
It's the line again.
Well, you can just
The
tell right
line
away
goes
that
all the way across.
Wait, let's do this.
nothing's greater than 3 and less than or equal to -3.
No, it's
Hey, where do those two overlap?
3. Never.
3
in the point.
At 3.
at 3.
Okay, but does the green part, Sean, is the green part graphed at 3?
Oh, no, it's not.
No, it's not because it's an open circle.
Yeah.
So, what do you think, guys? Any overlap here?
No.
What do we write?
No solution.
No solution. Confidence, please,
And why is
people.
there no? Why is there no
Oh, because
overlap?
one of them.
Look, if you look at them. Do you ever see anything overlapping between the green and the blue?
No,
That
The
would
kids
work.
thought it was the right on the number, right on 3, but the open circle green, that's not included there.
Shouldn't it be?
Wait, you
just
said that
one
the
If they were
that
both.
would override the
Yeah, and it should be
clear
closed.
circle.
I think it was on ors. If this were an or,
Oh,
It worked. That's what I was about to say.
It's an and.
this is an and.
If they were both closed, we're in a.
What if this were an or?
Then
you know,
Then it worked.
Then it'd be all real numbers.
Oh, what if I say, what if they were both.
I think that's where I was getting confused.
If they were both closed, we'd be 3.
This is tricky. You are going to need your notes to get your homework done. And you really have to understand the difference between the word and or. Sagara.
If both the circles were closed, it'd be 3.
Yes. Because that would be
Yeah,
overlapping.
Sean.
How many
Yeah,
special
sure.
cases out of like?
I have no idea how many there are.
No, but like how many problems do you think we're gonna have of these not special cases, just like the regular?
I have no idea.
There should only be like 2 or 3.
There's no 2 or 3 of each of special cases, 2 or 3 regular ones in the test. That's it.
What
Oh,
about?
Oh yeah.
There's
Oh, and all chapter 4.
How long
Chapter
is
4
it?
is easy though.
God.
There's regular inequalities, then there's
Let's go.
and
Solve this bad boy.
And then there's special
And there's
or.
compound inequalities.
Yeah, but that's mixed in.
Easy. X less than or equal to 6. Is this an and or an or one, people?
Or
Or
You know what, too many
Flippy.
I think I got it.
6. Remember, it's an or. 10. It's an or.
Got it.
Um,
This was like
What's
a
the answer,
regular
Nico?
special case.
It's gonna be 6.
10. Or as long as one of them's true, both of them are true. The less than or equal to 6 does not even matter. The green is the solution. Nico, how would you write that in set notation?
X such that X is less than 10.
no, you said for or problems that both of them matter.
No, it's for and.
Let's say and.
This is so easy.
And both of them matter.
And they both.
And is the
true.
overlap
It's
you're looking
easy.
for.
Yeah.
Or is
Can I
where.
write in interval notation?
And then how about interval notation, Nico?
Negative infinity, comma 10.
Kind of thing after the 10.
Parentheses, and then parentheses.
Perfect.
So easy.
Guys, you're gonna need your notes when you do your homework tonight. Okay?
Oh.
Signing off for the week. Everybody say goodbye, week.
Weeks off.